ads get put on this before people get to watch. Not going to necessarily be any code today. Today I am live streaming the video edit for the footage that I recorded yesterday for the 8 bits of image processing you should know video, which hopefully will release tonight. Now, this video, again, is part of my documentary series, sort of self-styled documentary series. I wanted to capture all of the things that go into making a simple video. And so far, we've spent about 8 hours getting to this point. So we've had 3 videos which are 2 hours each on coding, and we've had 2 hours, just over 2 hours of filming yesterday. We've got the edit today. I anticipate, again, it's probably, if it goes well, it's going to be 2 hours. It can take a bit longer for these shorter videos because I like to try and fine-tune them a bit, but we'll see. And then I'm not going to subject you to live stream rendering of the video and uploading to YouTube. I think that's a step too far. But I probably will live stream later tonight the launch after the edit once we get everything done. So, without further ado, I'm editing. I use a software called DaVinci Resolve. It's got a really nice free version that's got everything I need in order to make my videos. And here is the raw footage we captured yesterday. So these particular movie clips are from... oh, just a second, let me disable this. Always forget, I don't know why it automatically does it. See if we can get a few people into the chat to start us off. So these videos, these MVI ones, these are captured from the video camera, which is all the footage that we took yesterday. But alongside that, OBS was recording... start recording. Big file. You can probably hear. So this is just recording to disk now, and so this is 1 hour 40 minutes long. To show this is all the stuff that we recorded on the screen yesterday. And one of the things I've noticed is in video excuse me, in video editing software, it's too large really to sensibly handle. It's 8.18 gigabytes, whereas all of the others are 4 gigabytes. Now, I prefer a fairly snappy, responsive editing environment. So the first thing I do is chop up this file. Ah, Soviet Bill. Yellow. I'm going to chop it up. And to chop it up, I have a little custom script here which runs FFmpeg in the background. And it's just going to chop up the main file into 15-minute chunks. And that makes it very fast in the editing environment, because the way DaVinci Resolve works is it creates the videos in the graphics card memory and uses the graphics card to do all of the manipulation. So there can be a lot of file transfer between the CPU, the hard drive, and the graphics card. So I want to minimize it. If I use really large chunky files, everything sort of slows down. So I'm just going to drag that onto my little script, and that will go away and start to chop up the video. So just to explain, if you missed the beginning, this one, there's not really going to be any code, so it's okay if people don't hang around. I won't be too offended. But what we're going to look at is just the process as part of my series, ongoing. How do we go and create the videos? So we can see that's gone and chopped up that file now into a whole bunch of 15-minute long sequences. And these are about half a gigabyte each, which are a much more manageable thing. I've got quite a good solid state drive that I do all of my video editing on, just for this reason. Do you know why I'm coughing a lot? I need more tea. That's what it is. Let's have a mouthful of tea. That's better. Now, one of the things I'm not sure how well this is going to work is, of course, I'm live streaming and capturing the screen. So I've got one side of my computer doing all of this compression for the live stream. Now, my video editing software is absolutely going to suck any remaining resources I have left. You'll notice I have my headphones on today as well. It's because we'll be listening to the audio from the video. So let's start up the video editing software, which is Resolve. Vitamin T. I like that. I've not heard that before. Vitamin T deficiency. Absolutely. I'm going to use that one. I'm going to steal that joke. So Resolve. So these are all of the videos that I've created using this software. As you can see, there's quite a few now. I'm going to create a new project. And this is the environment. Now, what I've not shown anybody, maybe I can see how long the cable is. I don't know if it's possible. I have a little additional keyboard for video editing. Let me just see if I can show you that. So set the camera for a minute, which is here. I'll get my fingers out of the way. There we go. You can just about see it. It's a little left-handed keyboard, which I use to manipulate the video editing software. Put that back. Make sure I'm kind of in the right place. Humpa Lumpa. Hello. So, yeah, I'm not going to keep repeating the same message, but there's not really going to be any code in this one. It's just for me to record how do I edit the videos. Right, so I've got a new project here, and the first thing I'm going to do is save it and give it a name, and in this case it's 8 bits image processing. So far, nothing has crashed, so that's a good start. I then need to populate it with the clips that I'm going to use. So we've got the main video sequence, which was here. So I'll just pull those in, and it'll say something along the lines of, there we go. Project has a different frame. That's by default. DaVinci Resolve loads up. I think it wants something a bit more 30 frames per second. So I do change. There we go. And that's now, it's sort of in the default, whatever DaVinci has as its most optimal way of handling all of the graphics card transactions. Hima gets them. And these are now the chopped up clips, so these are all about 15 minutes long each from the recording yesterday. They might be a bit shorter than that actually. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, they can't be 15 minutes. They're probably more like 8 minutes long. Oh yeah, it says they're 8 minutes long, 7.5. Right, so it chops it up into smaller chunks. I'm just going to pull those into the media pool as well. So there's all of the video clips I want to work with, and the first thing I need to do is then pull them into the editing timeline. So DaVinci Resolve is split up. I can sit a little bit more relaxed when I'm doing this because I've got this little keyboard. DaVinci Resolve is split into 4 distinct sections. So you've got the editing section, which is where we're going to be doing all of the cutting and splicing and that kind of thing. And then we've got color correction and biting. This is a really deep tool, and this is completely free software. If you need to do video editing, I found this and I've never looked back. Totally free. It does all sorts of effects and 3D stuff, and I understand that it's used by the industry professionally. It's known for being great at this sort of thing. The free version, the only thing it doesn't do, well, certainly my version, is 4K stuff. And a few of the more advanced filters, but I don't use them anyway, so it's quite sufficient for chopping and editing video, and it's got loads of interesting ways of creating the video. The final window is the delivery window, which is where it does the rendering. You can set up all of the different rendering parameters. So I don't really need to ever go back to the media window once we've loaded everything in. They've appeared in this pool up here. So I'll just highlight those and pull in this is the video footage. Now you can drag these into the bottom, and I'm going to put them here, but then I'm going to unusually push them apart. So what we've got here is the blue one is the video, and the green one is the audio. I want to do it for all of them. So I'm just going to separate them by a couple of channels, and I do this so I can keep track of which one is which, because now I'm going to pull in the rest of the resources. I select them all. There we go. Lots and lots of things, and I'm just going to let Resolve go and chew away at doing those. It's got to go and create images for all of the graphics in the background. So I'm hoping we're not going to start dropping frames and things, because I'm already looking at the CPU and RAM usage on my machine. And there we go, so it's created all of the sound. Now I use the sound as sort of the cue for the editing. Now what's going to be confusing about this edit is, of course, the video we recorded yesterday contained lots of things in which are not intended for the final video. So we may have to think about a way to identify that. Fortunately I put in some markers, and I can put the cursor more or less anywhere now, and we can see that stage of the video. So we've got the 2 different cameras, as it were. But I now need to find a way of synchronizing these up. There are some built-in automatic synchronizing tools, but this software uses sort of an industry professional language, and it's not one I'm that familiar with. So I just tend to do it manually. And I just need to roughly guess where we started, because I think there was a point where I said I need to press record, don't I? I think it's going to be a bit further back yet. Looking at this, whenever I start to see these sort of blank sections, that's where I know I was in the video for real. If anything, I say that's about there. So start looking at the audio, and you can see that the audio from both microphones, one was on the camera and one was on the boom mic. Of course, they're reasonably similar. So I think that noise there, that click, is the marker that I use. In fact, you can see now in the image that was when I clicked the Zippo. So that's usually the only thing ever that clips. So I'll just get those synced up. Now, over time, as we start editing the video, it'll slightly go out of sync, and we'll need to correct this. But that's usually not too difficult to do. So I'm just going to see what that sounds like. Now that's recording. Now I can sync. Oh, I'll just turn down the desktop audio because that might be a bit loud. So now that's recording. Now I can sync. Good. Now, I'm not interested in all of the precursory introductory stuff that we did yesterday because remember I was filming sort of two videos at the same time. So I've got my two video feeds now in sync, and that's kind of, I guess that's the giveaway, is that they're almost switched off at the same time. And for the most part, I didn't do very much to camera yesterday, so I'm going to temporarily disable even seeing those. I think there was about 3 instances where I turned to the camera, and I'll be able to pick that up on the dialogue that's going on in the main editing. Anything else was just sort of background burbling noise, and we'll cut all of that out too. So let's start being a bit brutal. We know that the start of the video, because I had a few... And I've got to think, do I want to make life easy for myself or hard for myself? It's unusual knowing that people will be watching all of these mistakes. It's where that's going. So this is where I took a few attempts at the intro. Let's see if this was the one. Hello, it's been a while since I've done one of these videos, but this video is 8 bits of image processing you should know. And you might be thinking, well, why do I need to know anything about image processing? Well, images are just 2D arrays of data, and the algorithms that we apply to this data can shape it in useful ways. Obviously, some of the applications involve images and cameras and video footage. But there's also other ways of manipulating 2D data to your advantage, for example in things like procedural generation. So that sounds like that's the official intro. Now you may hear that the vocals sound ever so slightly phased, and that's probably because they're out by a couple of samples on the 2 tracks. I'm okay with listening to that whilst I'm editing, because ultimately it will render down to a single track, which I'm fine with. I think this was a bit of a pause, and then we've got... On the whole, I think image processing is... On the whole, I think most programmers should have a... Yeah, that's good. Oh dear. On the whole, I think most programmers should have an awareness of image processing. It is a very useful tool to have in your toolbox. Right, I think that was it. So what I'm going to do is deselect everything and do a sweeping cut. I'll leave a little bit of gap at the start because I like to do a fade in and cut all of the tracks there and simply erase everything before that. Hopefully this is going to erase squarely. Ah, thank you for the follow. Hello, it's been a while since I've done one of these videos, but this video is 8 bits of image processing you should know. And you might be thinking, well, why do I need to know anything about image processing? Well, images are just 2D arrays of data, and the algorithms that we apply to this data can shape it in useful ways. Obviously, some of the applications involve images and cameras and video footage, but there's also other ways of manipulating 2D data to your advantage, for example in things like procedural generation. I'm going to put a cut there, because I know we've got some errors here, and then we finalised on here, didn't it? It was about here. On the whole, I think most programmers should have an awareness of image processing. It is a... Yeah. So once we start getting going with this, it becomes a lot smoother. It's just once you've got to get that starting point up and running. So whenever I make a cut in between things... On the whole, I think most programmers should have an awareness of image processing. It is a very useful tool to have in your toolbox. So let's get started. Right, so that's the intro sequence done for both cameras. Now, I'm uninterested really in the main video feed now, because it was really just mostly 2 hours of the back of my head. So what I'm going to do is just remove that from the feed, and then I can just operate on the bit of code, which is the majority of what the video is, what we're looking at, just operating on what we see. But there's going to be a lot of sort of distractionary things. I think there's enough there like this for an introduction. I will, and that's the stuff we need to cut out. It's just a bit unusual knowing that people will... Now what I'm hoping for is that I'll see a general... I'm going to show you the application that I'm using to demonstrate these 8. And I think we had a couple of goes at that. Before I start, I'm going to show you the application. Before I start, I'm going to show you the video that I've created to demonstrate. Because it's working with video... Right, okay, so that's where we're going next. So I can lop all of that out. Now, yesterday I started off with lots of talking in the background and doing things, and then quickly that subsided into just getting on with the video. So the editing will become smoother. Before I start, I'm going to show you the video that I've created to demonstrate the 8 bits. And it's quite nice because it allows us to quickly compare the algorithms. Now, I try to take out sort of the longer pauses. So here it's going to show, even if they're only half a second, over the course of a 20-minute video, that could add up to a couple of minutes of just empty space. So here it's going to show the first bit, which will be thresholding, and we can choose different numbers to look at the different algorithms and see what their effects are. Because it's working with video, you can see here's a live feed of my arm waving around. I think it makes quite a nice interactive tool, which is great for learning. But this video is going to be a bit different to some of my others. I'm not going to go through it line by line from scratch. I've already created the code, and what I really want to emphasize is what is the image processing that is going on and how does it work. Right, so that's a typical structure of one of my videos, is we do the 2-camera intro, and then I do a sort of brief description of what this video is going to be about. We've not dropped frames, so good. It looks like on the whole my computer is coping with doing all of these activities simultaneously. Okay, that's good. I think that'll work. So now I want to go into OneNote and introduce the bits. So I'm going to draw a title card. Right, so I need a title card, so I'll choose the right... Code Slasher, hey, thank you. And I've got to think, do I want to make life easy for me? So I remember we drew the title. There we go. Let's see. It looks a bit more. Bit 1. This is the process of binarizing an image. I don't think I like that. Do we do that again? Here I have an image. Okay, it looks like that's what I've got, and that's what I'm sticking with then. So all of that can go. We'll just see how that transitions. Work. Bit 1. This is a bit too much of a pause. Bit 1. This is the process of binarizing an image. Now all of the others I read out the title, so that one's going to stand out, but all of bit 1 on the whole is a slightly bit different, because as soon as I finish talking about what this is, I then go and describe the framework code. Here I have an image. I'm going to assume it's a grayscale image, so the pixels go from black to white. Now one thing I didn't mention in the video yesterday is that I'm not using color images, so I'm already expecting a lot of the comments to be, well, why don't you use color images? So that's already starting to prime some thoughts in my head. Do I need to put a comment or something in the description? Thresholding involves taking an individual pixel and classifying as it... Thresholding involves... So there's a restart there. That's okay. It does. If anybody did see yesterday, it takes me about 20 minutes to sort of get going. Thresholding involves taking an individual pixel and classifying it as being... Lucky you're not using Premiere. It's crashed at least twice by now. For free software, I can't knock this. That's okay, Serious Bell. So it's not a coding stream
Thresholding
today.
involves taking an individual pixel and classifying it as being above or below the threshold. If it's above the threshold, you output 1. If it's below the threshold, you output 0.
Put stop in there.
This green line represents a
Thank
single row in our image.
So the editing is mostly cutting out white space and mistakes. I mean,
Not going
so let's
to
just
use
have
the-
a...
I'm not going to use the word luminance there. I'm going to use the word brightness instead, because not everybody, different languages and things, will fully understand what luminance is.
Right, so I can see, it's very subtle, but I can see there's a difference in amplitude when I'm doing the non-voiceover parts to just the regular chat. So it might actually all go a bit quicker, this. I'll put a cut there.
If I take this row and plot its x position against the brightness of that pixel, I might get something that looks like this.
Right, so there was a little bit of drawing on top of that. Let's get rid of that. Get rid of that pause.
Against the brightness of that pixel, I might get something that looks like this.
I'll just let that play out. Okay.
Thresholding involves specifying an appropriate value to act as a cutoff, so any pixels above that value will get classified as 1.
Yeah, I don't think Sony Vegas will offer me anything that this can't do, and this is $0.
As 1, and any below it will get classified as 0. The red dashed line represents my threshold value. So now, with my blue pen, I can indicate what the binary equivalent of this might be. So it starts down here at 0, but that goes above the threshold to 1. Below the threshold, above the threshold. And we've binarized our image. Right, I think that...
So it looks like we're cutting to code now.
To demonstrate these programs, I'm using a Pixel Game Engine application that I've already created. And I feel it's necessary to give you a brief overview of what this application is before we get stuck into the algorithm code, just so it makes some sort of sense. Fundamentally, it's based on the idea of a frame, which is a fixed 2D array of pixels, in this case 320 by 240. The pixels are floating point type. So instead of working with RGB values, I'm taking the RGB from the camera and converting it to a floating point value between 0 and 1.
So there's probably not going to be a great deal of voiceover from me once we get going, because it's...
By converting to the floating point domain from the integer domain allows me to avoid complexities such as integer division.
So it's also during this period that I try and listen and watch it all to make sure that everything's working out. And I think that's quite an important thing to do, because sometimes I'll talk about things but stuff won't be on the screen.
Value between 0 and 1. By converting to the floating point domain from the integer domain allows me to avoid complexities such as integer division. This simple frame class has some accessors, get and set, which will do boundary checks for me. So I can quite happily set a pixel's value beyond the edges of the image, and if I get something from beyond the image, it just returns a black pixel. So 0 is black and white is 1. My frame class also overrides the assignment operator. So I can have multiple frames in my application, and I can transfer the contents of one frame to the other with ease.
So when I'm doing the narration, I deliberately pause myself out just to give me some breathing space, gives me an opportunity to think, and also get the code in the right place on the screen. It's taken quite a bit of practice to get all of that to sync up in such a way that I can make the editing process as simple as possible. My first few videos used to take a couple of days to edit, and I realised I've got to change something about my workflow to make this more sensible.
For this video, I'm not going to dwell on the image capture side of it. I've done quite a few... For this video... move that back. For this video, I'm not going to dwell on the image capture side of things. I've already done that in other videos.
Now, one thing that Resolve is really nice in doing, you'll see that I'm doing these live cuts whilst the video is playing. It knows that my human response is not going to be fast enough to cut it at quite the right time. So it adds a little bit of a delay, and it's a perfect delay each time. So it does really make this process quite smooth. So if I
it's
click,
enough to say that we simply use the Escapi library to capture a frame from a webcam.
It's smart enough
So
to know what my intention
is initialized.
If I refer to other videos, yes, I do. I usually put a little card on the video. I don't put it in the text of the video, but I do put little cards on YouTube, which is what we'll see during all of the final prep phase of getting it launched and seeing what the response is like. So I've now looked at that whole section. I don't typically go back and re-watch everything because I've watched this as I'm going along, and it's simple stuff fundamentally. You know, it's not too complicated. But sometimes you'll see me going back just to make sure that a transition has worked.
On user create,
because if I've got it wrong, I don't want it to go every time.
Is initialized. And in on-user update, I capture the image from the webcam per frame and convert the pixels to floating point and store it in a frame called input.
So one of the things, maybe just whilst we're playing with the software and showing you what it's like, we can actually start looking at some of the tools that it provides, and you can see it becomes quite a sophisticated bit of software. So here we've got a node system where you can start to create your own effects and filters by connecting the different nodes together. So you pull in nodes from this list at the side, and all of this processing is done on the GPU. So you can do everything in real time, and you combine these nodes with the properties of your keys, your chroma keys, and everything else that you need to show. I mean, there's a never-ending bottomless pit of settings and toys to play with. It's got some cool things in as well, such as feature tracking and that kind of thing. And it's all live. So you can't really see sort of the data moving around, but you can start to see all of the graphs and everything changing in real time.
Capture the image from the webcam per frame and
hey,
convert
Lucas.
the pixels to floating point and store it in a frame called input.
So I think it's quite a sophisticated package.
This program shows 8 different algorithms.
Right, okay. One of the things that surprises me the most is, even though when I'm recording it, there's lots of bits I feel I'm not happy with that, I could have done that better, or I forgot to say that. When you actually get to the edit, you realise just how much it does all flow together. I think that's because when I'm recording the video, it is lots of gaps and pauses and things, and so it doesn't feel like it's flowing. But when you actually stick the edit together, it's not too bad.
Frame called input. This program shows 8 different algorithms, and so the bulk of the code shown here handles the selection.
I think, Lucas, you're missing the point of what this video is. You will hear my voice twice because I'm editing the video of me talking.
Selection of which algorithm is currently being demonstrated. And the algorithms also have a degree of user input, so we can change values to see how they change.
Oh, see, there's a little a gremlin there. Now, what did I do about that?
And the algorithms also have a degree of user input, which allows demonstrated. And the algorithms also have a degree of user input.
Okay, so I've got a repeat there.
And the algorithms also have a degree of user input. And the algorithms also have a degree of user input, which allows the user to change the values to play with the algorithm and see how they respond under different circumstances.
Okay, so all of that is dead. Now this looks like it's still code, yeah.
Different circumstances. For example, when the user presses the 1 key on the keyboard, it changes the current algorithm being demonstrated to threshold. So let's continue looking at that algorithm. Here it is, and you'll see this on most of the algorithms. We do a little bit of user input if there are values to change, and then we actually perform the algorithm under demonstration.
Okay. So I'm looking at the clock now. For whatever reason, and again it must be a movie industry thing, they start counting at 1 hour. So even though this sort of implies, oh, Geometry Crafters, hey, thank you. They say, it says here 1 hour 22 minutes 23 seconds and 15 frames. That's quite inaccurate. So we can probably help ourselves out a bit by firstly shuffling all of this to start at 0, but then it'll still say 1 hour, and I think it's just how the movie industry works. So if I go back to where I'm editing, so we're currently at 4 minutes 11 into the video, even though it says an hour at the start. I don't know, I don't like it, but that's just how it is. I code as I go. It depends. I mean, in this series, you've sort of seen some of the preparatory code that I do, but when I'm making the video, yes, most of the time I code as I go. It's also a way for me to double check the code. Oh right, yeah, I do need to update my version of DaVinci. The reason I haven't is I don't want something to upset my workflow, and I need to make sure it can pull in all of my old projects. I can probably set the start time code here. I don't even look at the 1.
Demonstration.
If that 1 turns to a 2, I know something's gone wrong. Right, let me just get back into the narrative.
Perform the algorithm under demonstration.
Okay.
And thresholding is very simple. For all of the pixels in the frame, we read the input value of a pixel for that location, compare it with a threshold value, which will give us a 1 or a 0 in response, and then we write that to an output frame. At the end of the program, I then draw the input and output frames.
Okay. So when it's a topic that I'm particularly comfortable with, and image processing is one of those topics, I find that the editing can go a lot smoother. There's a lot fewer mistakes that I make when I'm recording.
Hopefully you can see thresholding is very simple indeed. So let's take a look at it. This is thresholding. Now my webcam has some automatic gain correction, which is what you saw then as the image sort of changed and faded. I can't override those settings using the API for the camera.
Now, I like to include little bits of information like that because some people who will not really understand these things because they haven't learnt them yet will say, well, hang on, why did it all change? Why, when you started the software, did all of the levels change and things? And so it's not always obvious. Don't forget, some people aren't as skilled or as knowledgeable as yourselves.
This is thresholding. Now, my webcam has some automatic...
Yeah, okay. So bit 1, thresholding, happened to be the longest bit, but
for this video it doesn't
we had
really
all
matter.
of this extra
I'm
explanatory
in threshold
text
mode now, and we can see the input image here on the left is in grayscale, but the output image here on the right is in black and white. It's been binarized. And it says here I can use the Z and X keys to change the value of the threshold. So currently it's at 0.5. It's halfway between the minimum and maximum intensities for the grayscale. As I increase the threshold value, we see less pixels being attributed to a binary 1. And as I decrease it, we see the opposite.
What's the Y2 there? What would it make you calculate the length of your... What would it make you calculate the length of your vid movie? Sorry, I don't understand the question. Why would it make you calculate the length of your vid or movie? Still don't understand the question. You're talking about the timestamp thing. I think that this is just the current position. Yeah, this is where the marker is currently, and so I know that given that I start my video at 0, and we've done all of these cuts and edits, right now where the marker is the current length of the final film. Right, this looks like not...
Thresholding is essentially...
Oh yeah, we want that, okay.
Thresholding is essentially the coarsest of filters.
I also, when I hear, I make an assertment like that, you know, I just want to double check in my own head, is that true?
Is essentially the coarsest of filters.
And
it is usually the first step
it is.
in removing as much rubbish from an image as you can. For example, here you can see on the notebook the text one lone coder comes through quite clearly, but the lines and the slight greyness of it doesn't. So if we were then to go on and extract this text, for example, it's much easier now. We're not contaminated with this spatial background noise. We've thresholded it out.
Right, I think that pause there is a little bit... I'm quite interested in the cadence of the text, so sometimes I like to just nip things up. Now I have to be careful when you're dealing with live images because you see them stutter.
We're not contaminated with this spatial background noise. We've thresholded it out.
Yeah, the cadence is better there. Okay, so I think that's probably sufficient for that one part. And there's not much to a threshold, it's simple. I also quite like the flow there. I'm not bringing in code, okay, it's just me talking. I really don't want to make a really long video. Yeah. And some of these things are going to require... So I think that's the start. So up to bit 2.
Bit 2. Motion. And for this video, I'm assuming the simplest kind of motion. We won't be able to get any direction information from this.
Yeah, I guess it's just me talking, but there's a strange situation yesterday of me doing 2 videos at once at the same time with a single camera.
Information from this. The word motion, simplest kind of motion. We won't be able to get any direction information from this. The word motion implies that something has moved. And for something to move takes time. So
it's always satisfying when you take a huge chunk out like that.
So to detect motion in an image, we need to allow time to have elapsed. Fortunately, with video, this is quite simple, because a video camera returns successive frames in time.
Now, one of the things I've learned is that I don't mind cutting short the animations in the OneNote. So even though sometimes I want to draw things out, wiggles and squiggles and lines and things, I don't sort of watch me draw them all out. I used to do that in earlier videos and realised, hang on, I actually quite like the sort of scruffy PowerPoint look that it gives it by having these harsh cuts in it. So that's something I go for.
Which means we have a built-in delta time between each frame.
Now I have a thing that when I open my mouth there's always a at the start. So often I can identify that with this little tick here at the start.
Alongside,
I play that again.
Alongside,
and you won't hear that in normal day-to-day, but just because I'm sat on top of a microphone, that's why you can hear it. So I always try and use that as a guide for where I want to do the cut.
Alongside movement in time, motion also implies movement in space. The object was in one location and now it's in another.
Hey, we're tearing through the footage here. You know, my video of this yesterday, it's already got a dislike.
But for this bit, let's not think of objects as being the things we're looking at. Instead, we're looking at pixel grayscale values. So over time, I'll put an axis in. So over time, if something is moving in the image, a particular pixel value is also changing. So we can identify that motion has occurred by looking at the difference of pixel values between successive frames of video input.
Is there? That was one of the things I was curious about the new version of Resolve. Is this one? It does all of these great fancy video things, but it has no audio facilities at all. Well, I was just surprised because it's on my sister channel, so it's not got anywhere near the audience as the main channel. And it's very upfront about what the video is and how what it's about. And I just thought, well, why has somebody gone on to do that anyway? I'm not fussed by it, but it just struck me as odd. I think some people honestly expect that every bit of content that I put out there, be it on Twitch or be it on YouTube, has to be some sort of novel code they haven't seen before. I got a comment yesterday on YouTube which irked me slightly. Basically, a guy saying, 6 months ago I asked you to do a video on this and you've not done it yet. When's it going to happen? And I thought, well, I don't do these things to order. Did I put a cut there? I didn't put a cut there. But how dare he assume that I do these things to order?
And so on this graph, we can see that the difference between A and B is related to the change in that grayscale value.
Captain Assist, thank you. Just going to take out a little bit of a pregnant pause there.
Frames of video input. And so on this graph, we can see that the difference between A and B is related to the change in that grayscale value. The end result of this could be signed, and in some applications that's a useful thing. It gives you additional information. But for our application, I'm just going to take the absolute value of this to tell us that motion for that pixel is likely to have occurred.
Yeah, again, same sort of... For me, the cadence isn't right there. It doesn't feel like it flows too well, so I'll just play that back.
I'm just going to take the absolute value of this to tell us that motion for that pixel is likely to have occurred.
Yeah, that's better. I read every comment that I get sent. I can't sensibly reply to them all now. Whereas I used to make a thing of trying to reply to every single comment. I physically can't do that now, which is a shame. I mean, it's nice on one side, but it's a shame on the other.
The code for motion detection is equally as simple as thresholding. I'm going to go through every single pixel in my frames with these nested for loops.
Anyway, this particular comment was about recursion. And I do actually have something in mind to demonstrate recursion. So when somebody gives me an idea for a video, They don't get forgotten about. I've got a list of all of the things I'd like to talk about. But recursion on its own doesn't make a sensible video. I do record video and audio at the same time, yes. What was I saying? So recursion, it wouldn't just on its own wouldn't be a very interesting video, but I've got a plan to merge it with an algorithm which exploits recursion, and so I can kill two birds with one stone. I think that'll be a much more interesting video. So these things, they will happen, but they just take a bit of time. I've got to find the right vehicle to talk about them. Well, that's the thing, right? Who cares about Fibonacci? Because this is the problem with computer science tuition today. Is, oh right, now we're going to learn about, now we're going to do Fibonacci. Who cares about the Fibonacci sequence? Yes, it demonstrates recursion, but it's just so boring. Who cares?
Frames with these nested for loops, and I'm going to look at the difference between the current frame and the previous frame by subtracting them. I'm then taking the absolute value of that result and setting that in the corresponding location to the output frame. I then draw the input and output frames.
So yeah, Captain Assist, if you didn't see yesterday, I launched a video which was the raw footage of all of this being recorded in the background. Oh god, they're getting longer, these names. Pancreas Dragonheart, thank you very much. Yeah, that's kind of it. Hello, today we're going to talk about recursion. Exactly, right? It's on its own. It's just not enough unless you start trying to come up with all of these artificial examples of why it's a useful thing. I rarely use recursion myself. I think sometimes it's just a bit too dangerous.
I then draw the input and output frames. I update the previous input frame before I acquire a new image in the input frame.
Let me just play that. So yesterday, that stuck in my mind that it didn't sound very well.
I then draw the input and output frames. I update the previous input frame before I acquire a new image in the input frame.
Yeah, I mean, it makes sense in the context if you've got the visuals, but if you're just listening to it, that's quite a confusing statement. Anyway, it is what it is.
Here's the algorithm running, and it's looking at a reasonably static scene. But as soon as things start to move, I bring my hand into the scene, we're looking at the difference between one frame and the previous frame. But we only see illumination in the output where there has been change, so that signifies that motion has occurred in those locations.
Now I've got to be careful when I'm working with moving images that when I start cutting the audio that the imagery doesn't start to look strange.
Because the frame...
So you see, this is a little bit of experience that I've got now is I'm aware of that. So I kept very, very still.
Because the frame rate
so
of my
if I did
camera
have to make a cut, it wouldn't be
quick,
as
it's around
obvious.
20 frames per second, I get what looks like an edge around the object that's moving. But don't be fooled by this. It's not strictly an edge, although you can use it as an edge.
It's exactly the same when I'm scrolling around the screen in code or when I'm showing things moving in a game. I always stop the movement if I'm not doing the talking, just to make the cuts a bit easier. Yeah, Lucas, that's it's the first time I've done this. It's this whole series this week has just been, I wanted to capture every single minute of how I go about creating a video, and I thought, well, I've got this nice idea for a video. It's short enough to be able to do this with. The Car Crime City ones, for example, they take a long time. And I think what it will hopefully emphasise to people is, in total this week, I'll have put out, I think, around 10.5 hours of material just to create this one video. And that doesn't include all of the years spent at school and university learning all of this stuff in the first place. So there's a lot of effort goes into even a simple video like this. And so sometimes it's frustrating when you do something like people going, well, where's the next Car Crime City? Where's the next one? Where's the next one? Well, you know, I work full time and I've only got so many hours in the week to dedicate to doing YouTube, and I want to talk about other things other than Car Crime City.
It as an edge. It is just the difference between the two frames.
There we go. Yeah, that's good. Oh, hey, Wes.
A useful application of this is to...
Oh, that sounds like it had died. So let's try moving over here.
Motion detection like this
That sounds better, yeah. So I don't think we're going to get a clean cut between the video feeds on that one.
Between the two frames. Motion detection like this is usually a foundation algorithm. It is used to guide your decisions in subsequent algorithms that you apply to the image.
Just take out that pause. So as you can see, I edit very linearly. I won't go back now and start changing the order or sequence of things, unless I'm doing some intricate video where that's a requirement. It's a very linear sweep through the video, trying to cut out all of the material that didn't work. And that's taken a bit of time and practice too, because I really need to minimize the amount of editing time. I do enjoy it, but it's a bit tiring listening to your own voice for a whole afternoon.
Shut down if nothing in the scene is moving. I mean, why bother taking more images if nothing has changed? So I could detect that.
Yeah, okay, can take that one out.
So I could detect that by accumulating the sum of all of the pixels in the output image, and then checking that against a threshold value to tell me, has there been enough motion in the image for the system to switch on?
I've got used to it now, Captain Assist. Thank you, Wes. I'm pretty good, thank you. I watched you slave away to... It's okay. I don't mind. I mean, it's my hobby.
In the image for the system.
I just wish there was... there's parts of it that just take longer than I would like. I'd love to be able to just dump this part on somebody and say, go away and edit that, please. But then when they do it, it won't be how I envisaged it, so I'll have to end up doing it myself anyway.
I feel that one went quite well too.
Oh, yeah, so we've got a context change there, so that's where I'm talking to the original camera. Okay, so all of that, blah, 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 blah. What does it look like we get to the next bit?
Back to the OneNote.
Yeah, so I can tell by the amplitude that this is not necessarily relevant material. I think it's more likely to be there.
Basically, it's taking motion.
No, it's not really. Well, it kind of is. It's kind of.
See, the
We'll find it. Yeah, I did a sort of rough cut first, didn't I?
Bit 3.
There we go. It's strange because I've done this now for so many hours on over 2.5 years that you can start identifying what's being said just looking at the amplitudes of the output sound. It's weird.
Bit 3. Low pass temporal filtering.
I don't tend to add any dissolves or anything like that. One of the things I have found Resolve struggle with, not necessarily on this PC, but on my work PC where I use it to make videos for work, if you do dissolves on the same clips, if you try to dissolve a clip with itself, it really doesn't like that at all. I have an idea on how to fake a slow motion camera. Basically, you get the edges of all objects in one frame, then apply a room algorithm. Repeat that with the next frame and then check what room looks the most like the other room and then linear interpolate between the... Well, that's actually what the... I don't know what you mean by rooms, but I think I get the gist of what you're saying here. That's what these smart televisions do where they're trying to upscale to 60 frames per second. They make estimates of how things have moved and then try and interpolate it temporally, and they always look a little bit soapy. Well, it's optical flow is where that is going. And it's optical flow on a 4K panel will probably just not be feasible yet with current processing technology. So I imagine it's nowhere near as sophisticated as optical flow. If anything, it's probably broken into 4 or 5 regions of global flow rather than local flow, which would be completely sufficient. I mean, you're talking about something that's on screen for a handful of milliseconds.
As we've just seen in bit 2, the value of a pixel changes over time. And if we look over a longer period of time, we might see that the pixels change values quite rapidly.
So here is a candidate for just
Between
speeding
frames.
up the video.
This is called noise, because sensors aren't perfect.
So I might just do that. What I'll do is I will remove that clip, and I'll just to slightly pull it up a little bit. Change clip speed. Lost it. Where is it? Change clip speed, and I'll set that to ripple the sequence, but I'll maybe just quickly. It'll only save like half a second, but I think aesthetically it'll look a little nicer.
Change values quite rapidly. Between frames.
Yeah.
This is called noise, because sensors aren't perfect. Lighting conditions, electronics, and all sorts of things can influence the value of a pixel.
Okay, Wes, I might do some video games next week. I've had a really solid month of doing video content. So the Car Crime City stuff a couple of weeks ago made that sort of 1.5 hour feature length thing, and this week I've done lots and lots of live streams to produce this little mini documentary, and ultimately this video. So I might treat myself to a small break after this one. We'll see.
Value of a pixel. This noise can cause us problems, because what we actually want to see is the real value of the pixel change over time, which is indicated by this green line. We can approximate that that's somewhere in between all of these noise values. And noise can become a problem if you do things such as thresholding, because the noise might just tip you above or below the threshold inappropriately. We effectively want to run the grayscale value of the pixel through a low-pass temporal filter. So the low frequency component of the pixel is allowed through and the high frequency components are removed.
I have seen other plugins which remove all of the video where there's no sound. I just think that's a recipe for disaster, particularly when I'm showing code sometimes. I like the fact that my videos end up being a fairly measured pace. Right? They're not meant to be a, hey guys, what's up, smash that like button, let's talk about some code, here's some algorithms, let's go, now. Right? They're not like that at all. They're a nice
filter. So the low frequency component of the pixel is allowed through and the high frequency components are removed.
Exactly. How many YouTube videos start with, hey guys, what's up? If people aren't smart enough to know there's a like button, then they probably shouldn't be watching my videos.
We can approximate this with a very simple equation. For a given pixel value, p, we're going to update that pixel value by looking at the difference between the input pixel value and the current pixel value
Now, this was a tricky one to explain because I'd really wanted to have gone down, let's explain this as a series of RC equations, and even perhaps draft in an electrical schematic. But then you've got to think, well, the context of this is people just want to see it do what it's doing. They don't necessarily care how it's doing it.
Current pixel value and multiplying that by a constant.
I did my tau wrong, didn't I? It was a bit wavy.
Drew my tau incorrectly there.
Yeah.
and multiplying that by a constant.
Well, I think that's. Yeah, I think you're right there. I don't feel the need to sort of ask people. I suggest to people at the end of videos if they've enjoyed it to do it, but I've never sort of said, "Hey, you must do these things." It's up to people what they want to do. Right, there's a big section to cut out. So we're already on sort of bit 3, which is pretty good. We're making good
Fundamentally,
progress.
if this distance is small, then the change in our output pixel is small, and if it's large, then the change in our output pixel is large. But we can regulate that change with this constant.
I think that'll do. A quick look
I
at the
agree.
code.
In engineering, this is also known as an RC filter.
Just want to replay that transition.
Regulate that change with this constant. In engineering, this is also known as an RC filter. And its implementation is very simple. In the low pass section of the program, I'm doing some user input so I can change this constant value.
Seems weird saying change this
I'm
constant.
doing some user input so I can change the value of this temporal constant.
Yeah, so I did actually change that.
Is very simple. In the low pass section of the program, I'm doing some user input so I can change this. I'm doing some user input so I can. In the low pass section of the program, I'm doing. C filter, and its implementation is very simple. In the low pass section of the program, I'm doing some user input so I can change the value of this temporal constant.
Just like that, eh?
And then I iterate through all of the pixels in a frame. I look at the difference between the input and the output.
That felt like I stopped
I
prematurely.
scale this distance with our constant value. I scale the difference with our coefficient.
I said, yeah. I said distance. I'm sure I said distance.
I scale the distance with our temporal coefficient.
Okay, seems a bit better. Yoink.
And the output.
Oh, always remember to click save periodically.
Between the input and the output. I scale the distance with our temporal coefficient. Oh, come on, David. I don't even know what I just said then. I scale the difference with our temporal coefficient, and then I accumulate that difference back into the output frame with this plus symbol.
Maybe I don't need the plus symbol bit, but we'll see. So that was obviously reference to that. Get rid of you. So let's just have a quick recap.
I look at the difference between the input and the output. I scale the difference with our temporal coefficient, and then I accumulate that difference back into the output frame with this plus symbol.
I'll keep it in. Somebody's going to comment on that, but I'll just take out the pause.
Into the output frame with this plus symbol.
There we go. It's all smoke and mirrors.
For this algorithm, the output frame is persistent between updates of the video camera feed. Meaning that output pixels are only changed by a small amount depending on how large the change was of the input.
I've never thought of YouTube as a verb before.
Depending on how large the change was of the input. So here in the program, I'm now running bit 3, the low pass temporal filter, and the two images look very similar. It might not even be that possible to see on the YouTube video, but the input image on the left actually has quite a lot of per pixel noise, but the output image
So I was just scrubbing there to make sure which word it needed to be cut on.
image on the left actually has quite a lot of per pixel noise, but the output image on the right has no temporal noise visible to the naked eye. If I move my hand into the scene, this is a particularly slow filter, so I can make rapid changes sort of by wiggling my fingers around here, but we can see that the output image doesn't change very much. It's ignoring those fast changes, only allowing the really slow changes. If I leave my hand in a fixed position, eventually it feeds into the image. So this is exaggerated in a way. I can use the Z and X keys to change the value of this constant. So I can make it very slow indeed.
Right, so am I wiggling my fingers here?
Into the image. So this is exaggerated in a way.
Okay, that's just dead space. I can go.
In a fixed position, eventually it feeds into the image. So this is exaggerated in a way. I can use the Z and X keys to change the value of this constant. So I can make it very slow indeed. Which might not immediately seem a useful thing to do,
that.
but if you wanted to do some background subtraction algorithms over moving images, this is quite a nice way to do it. You can accumulate the background of an image over time and then use that as a way to isolate things in the foreground. If I increase the value of the constant, it becomes far more live. Let's keep going a bit. Until the two images look very similar indeed. But if you get it too high, this constant, you'll start seeing the per pixel camera noise coming back into the output image. So, low-pass temporal filtering is a great way to filter noise. And it also looks all ghostly and cool.
Keep that bit.
Great way to filter noise. And it also looks all ghostly and cool.
Right, what's the next one?
Bit 4. Convolution.
Now, this is always going to get a bit fiddly because I didn't want to dive into sort of the mathematics of convolution. And I think I do actually have a two-camera bit here where I suggest that actually there's, particularly with the morphological operations, that might make its way into a separate video later
Bit
on.
4. Convolution. Whereas the previous two bits have looked at filtering things in the time domain, convolution looks at filtering things in the spatial domain. Fundamentally, we're going to decide what to do with a pixel by
Spoiler territory.
Fundamentally, we're going to decide what to do with a pixel by looking at its neighbourhood. For this example, I'm going to look at the immediate 3x3 neighbourhood of our target pixel.
Okay, so some awkward pauses there. Just lock that. So I'm pretty pleased that so far we're halfway through the video and we're only up to 13 minutes, and two more of these bits are actually quite short in comparison. So I'm hoping that we'll not really go beyond the 25-minute mark.
For this example, I'm going to look at the immediate 3x3 neighbourhood of our target pixel. Three by 3 neighbourhood of our target pixel.
Now, if you didn't watch the video yesterday, and I've no nothing against if you didn't. One of the things I don't use is a script in any way, so that's why sometimes I make the editing harder for myself.
And this neighbourhood is called a kernel.
"19 minutes in total." I think that's just for this current clip, isn't it? According to the timeline, technically there's an hour and 19 left. So that's why it's quite a confusing thing. But you see, even though this looks horrendous, like, oh my god, there's loads and loads left to do, most of it's empty space. So by the time you get it down, we're halfway through, and it just looks like that. It just all gets crushed up. No, I've not got time to sit writing a script.
Kernel.
Fortunate enough,
think of a kernel as a template of coefficients.
I'm fortunate enough to have had quite a bit of teaching experience and speaking out in front of people, so I don't mind being able to. I don't find it that difficult.
That are used in a dot product of the neighbouring pixels in that region.
Yes, I think this gets a bit bogged down.
And values of the kernel to give us a result for the central pixel. So my kernel might be defined here as a 3x3 matrix of values.
I think the OneNote pictures look particularly lazy this time around. I have thought about moving from OneNote to something that's a bit more professional looking, a bit more animation style, but then it's just more time to do all of that.
Central pixel. So my kernel might be defined here. So my kernel
But I think I've become a little bit known for sort of the scrappy OneNote
might
stuff.
Be defined here as a 3x3 matrix of values.
Yeah, that's what I like to think. Hey, Tezza. Sorry, I'm sort of focusing with one eye on the chat. Yeah, I do too. I like the fact that it shows that you don't need lots of fancy tools. A bit of pen and paper and putting the time and effort in. I mean, that's really what this whole One Lone Coder thing is about. One of the things I try to avoid, and I know sometimes it may come across this way, I don't want it to be a show-off vehicle. I'm not here trying to demonstrate the things that I know and look how great these things are. I want it to really be about, look, these are things that perhaps you should have a think about learning for yourself. So I'm always conscious of that. I'll never say in a video you should do this or you shouldn't do this, because I don't really want to come across like I'm some sort of authority in any of these topics.
These values are overlaid over the corresponding pixel in that location. And we also include the central value, which is the target pixel. I can give these kernel values location information to identify the relationship to the target pixel.
Yes, I felt like I was making this one up a little bit. I hate that noise. Doodle-doo-dun-dun-dun. I'll have to change that. I'm just going to play this one back a bit because I've been a bit distracted by chat and other things. I just want to see what we're sounding like.
That are used in a dot product of the neighbouring pixels in that region and values of the kernel to give us a result for the central pixel. So my kernel might be defined here as a 3x3 matrix of values. These values are overlaid over the corresponding pixel in that location. and we also include the central value, which is the target pixel. I can give these kernel values location information to identify the relationship to the target pixel.
So here I went through and drew them all out. Where did that stop? Conveniently, that's probably good enough. Just quickly save. I've had, as much as I like DaVinci, sometimes it does just freeze up on you. And I'm going to chop that there. And I'm going to remove this clip. And we'll speed that one up. Ripple sequence, I think, looking at the length of it, we'll go to, come on, 800. Nice and quick.
To the target pixel. I work out my final pixel value by performing the dot product between a kernel coefficient and the grayscale value of the pixel at that location.
Okay, yeah. Kinda comes together. This bit I was unsure about, and I don't know if it's going to stay in. That could be a good enough place to just leave it.
So this component, for example, is this component of the kernel multiplied by this pixel value. And we go on to go through all of the kernel locations.
Just felt a bit like I was labouring the point. I don't know, what do you guys think? Should I keep it in or cut
Multiplied
it out?
by this pixel value. And we go on to go through all of the kernel locations.
Well, let's see, where did it go in the end? I'm sure there was a part. Yeah, there is. It did. It kept going. Tell you what, I might cut it. Draw the arrow. I'll leave it there.
Of the kernel locations.
And I'll not include the rest of these. So a bit of both.
And so what effect do you think this kernel might have then? Well, we can see it as being regions of influence. We're strongly influenced by the target pixel, the one in the middle. But we're also a little bit influenced by our immediate north, south, east and west neighbours. Conveniently, in this kernel, all of these values add up to 1.
Yeah, see, this could get confusing for somebody. Why is there a significance of it adding up to 1? Because then you go on to show a kernel where it explicitly doesn't add up. Oh no, it does add up to 1, doesn't it? -4, -4, -4. +5, I think it was, wasn't it? Was the other kernel. Oh, well, we'll see.
Up to 1. And this is quite deliberate. So we take the bulk of our pixel's value from what it already is, but then we take a little bit from its neighbours, but we still land within the approximate range for that pixel. This will give us the effect of blurring the image. Because we go on to apply this kernel for every single pixel in the image.
Sometimes I do, sometimes I don't. It depends if there's a trade-off. If I can find sort of the best way to do something that doesn't
single
rely
pixel
on
in the image.
really complicated code that somebody's got to go and digest, then that's the way I'll demonstrate it. But there have been many times where I don't optimize any of the code just in order to keep it clear, and this is exactly one of these examples, coincidentally. Convolution. This is a rubbish way to do convolution, really, and it's only good for 3x3 kernels, and I actually go on to talk about that to the camera, so we'll see that in a minute.
I've implemented convolution in a really naive way.
See?
Here I'm going through every pixel in the frame. And for each location, I'm accumulating into an fsum variable.
Well, that's it. It's really about dropping words that people can Google. If people go away after my videos and Google
My
a few
kernels
extra topics,
are 3x3, but I want to get the corresponding offset location for a kernel coefficient in my image. So I've got an additional 2 nested for loops, which iterate through the values in my kernel.
This was always going to be the tricky one to edit, I think.
The kernel we've just created is a blurring kernel, and I'm representing that as just an array of 9 floating point values. I index into the appropriate location.
Okay, bit of a restart there. Excuse me.
Of 9 floating point values. I index into the appropriate location of that kernel using some simple 2D to 1D arithmetic. Once I've got the right coefficient, I multiply it by the input grayscale value and accumulate it into my fsum variable.
See, I wanted this video not to be about, hey, you've never coded before, but for some reason you've got an assignment which involves image processing, so this is what you need to do. So that's why I've deliberately avoided going into really any detail about how the code works and what the sums are doing, and just sort of introducing what are these techniques and why are they cool to look at.
1D arithmetic. Once I've got the right coefficient, I multiply it by the input grayscale value and accumulate it into my fsum variable. I then set my output pixel for that location to the fsum variable. In this demonstration, I've included 2 kernels, blurring and sharpening. The mechanism for convolving the image is exactly the same for both, but the coefficients of the kernels are quite different. There's a little bit of user input at the top to choose which kernel we're going to apply to the image. Here I've chosen the convolution component. Of the program, and we can see the input image on the left is nice and sharp, but the output image is ever so slightly blurry. I might be able to enhance
it wasn't blurred enough, and if it wasn't blurred enough, I have to do a whole bunch of extra code.
Start that again.
Oh dear, I obviously wasn't happy with that in the day. A bit concerned that I'd have to then go about iterating through multiple convolutions.
In the demonstration program, I've chosen bit.
Okay, I always go with, if I've decided to redo something, it's going to be better than what I did at first. So I never give it the second chance.
In the demonstration program, I've chosen bit 4 convolution, and it's currently running the blur. In the demonstration program, I've chosen bit 4 for convolution, and it's currently running the blurring kernel. And we can see that the input image on the left is sharper than the output image on the right. This blurring only occurs once over a 3x3 neighbourhood, so it's a very delicate blur.
Right, so let's just get back on track here.
In the demonstration program,
So that can go, and I think that can go.
there's a
That's
little
code.
bit in the demonstration.
Right, so it's just those two. That can go, that can go, and that can go. So once I've made a load of multiple clip changes like that, I'm just going to...
In the demonstration program, I've chosen bit 4 for convolution, and it's currently running the blurring kernel. And we can see that the input image on the left is sharper than the output image on the right. This blurring only occurs once over a 3x3 neighbourhood, so it's a very delicate blur. However, if I press the X key, I can change to the sharpening kernel. And we can see that this kernel has the effect of enhancing any areas of high contrast in the image. You may have seen these filters in popular art programs.
So in fact, if you go into Photoshop or Affinity or anything else, GIMP certainly has it too, there's always an option to enter some coefficients into a kernel matrix and apply that.
The downside to sharpening, of course, is it also sharpens all of the noise. So we may want to combine convolution.
You see, when they start looking at this in full screen mode, is it possible? Yeah, you can see the noise
With some of the previous filtering algorithms we've already seen.
Okay. See, once it's run through the compression that I put on the video, and then once it goes up to YouTube and gets compressed again and processed, whether those sort of things will be visible or not, I'm unsure. Now, it looks like I've got a little indicator here. Yep. So that's a little Zippo snap. It's telling me I'm going to do something to camera. So I'll pull in the camera feed. It's important I get the turn. Now this may sound a bit phased and out of sync.
In this simple demonstration of convolution, I've used a very small kernel, 3x3. Well, there's 4 lots of nested for loops in implementing this. So if you increase the size of your kernel, suddenly there's a lot more computation.
Yes, I do, Tezza, yeah. Only because it makes a nice little visual snap I can identify in the sound stream.
Computation to perform.
I think I did all this again, didn't I? I said this is rubbish.
Another approach is to
Here.
I'm going to start that again. I kind of know what I want to say, but it all came out a bit scrambled. In this
Trademark turn. Well, it's the only thing I've got to hand, which is a nice visible snap. It's a bit too long. Yeah.
Algorithms we've already seen. In this convolution example, I've used a very small kernel, 3x3, so it can only look at its immediate neighbours. For blurring, for example, if we wanted to have more of a blurry image, there's 2 ways to go about it. The first is we could repeatedly blur the image, so once we've blurred it once, we then use that as the input and blur it again, and again and again and again, until we've got the desired level of blur. The second approach is to use a much larger kernel, so we can go 5x5, 7x7, 11x11, whatever you want. But the kernels and the convolution I've shown here are 4 levels of nested for loops. It will explode computationally and become very slow and difficult to get any kind of real-time performance. If you're serious about doing convolutions, and most image processing techniques and programmers are, then you'll want to do your convolutions in the Fourier domain, the frequency domain instead, where you take the fast Fourier transform of your input image and your fast Fourier transform of your kernel, combine them, and then take the inverse Fourier transform of the result. And this will allow you to get very large kernels with a fixed computational overhead, a far more suitable approach for real-time image processing.
Okay. Right, so we'll do a little bit of tidy up. Because it looks like here I can see with the change in amplitude that I then go back to talking. Right, so I'm just going to save, but now I've started. It's my first bit to camera after the intro, so I want to get rid of the code vocal.
In this convolution example, I've used...
But in all of the code sections now, I want to get rid of the Oh, wrong. Undo. I want to get rid of the camera.
noise. So we may want to combine convolution with some of the previous filtering algorithms we've already seen. In this convolution example,
Now, channel 1 audio is a little lower, so I'm just going to amplify that and try
we want
and
to
balance
combine convolution with some of the previous filtering algorithms we've already seen. In this convolution example, I've used a very small...
Okay, that's a bit more balanced. So now I just want to identify and get rid of a few of these, just so I can see where it starts. And I want to go back to where my intro finished. Here.
in things like procedural generation. On the whole, I think most programmers should have an awareness of image processing. It is a very useful tool to have in your toolbox. So let's get started.
And that's the cut to the code. So that is a marker there, and we can get rid of you, and you. So all of those gaps, because we had no other two camera components, they can all go. Right, so then it was me waffling on about something else for a bit.
That could alienate beginners very quickly, so it's important to get those things in.
And I'll just shut off the video and audio again, because I can't remember where the next to camera bit was, but I think there was only one more.
5. Sibel.
Cut there. So this is just waffle junk. That can come out. Certainly the best thing I invested in making these videos was this little left-handed keyboard, where it's got a built-in mouse I can use with my thumb, which I can use to pan the scene, and I can also zoom in and out with it. And I've also got my normal mouse with which I can select things. I've got keys for doing a cut, keys for doing a delete, keys for undo, keys for save, and also start and stop, all mapped out in basically a WASD kind of pattern. And it just really, it's nice on the hand, it's comfortable. How am I able to make the video with a slow pace while having so many cuts? I think I may have mentioned that before, is I deliberately leave pauses in whilst I'm recording, so I can just make sure everything is what I want it to be and how I want things to sound. So where did we put that cut? Was it there? No. Oh, we've done it. We've done it already. We're actually up to the right place. Bit 5.
Sibel edge detection.
So I can probably say that exactly. Bit 5. Sibel edge detection.
Detecting edges in image. Detecting edges in...
Detect edges in image. Proper Neanderthal mode.
Detecting edges in images is perhaps the most useful thing to start. Oh, where am I going with this?
So I can tell with the amplitude that I
perhaps the
wasn't
most
happy
useful
with
thing.
where it went. So what's this one?
Edges in images for the information.
Just waiting for the GPU to catch up.
Is in images detect. No, hang on. Start again.
Okay. So I've just made all those edits, so it's doing a load of transfers in the background to shuffle the relevant stuff to the graphics card and back.
Edges in images
It's caught up.
indicate where the information of an image is.
Well, yeah, I guess that's kind of true. It's where the high frequency components of the image are, and usually it's the high frequency components that contain interesting stuff. That's the point I'm trying to make here, but we'll see how well it comes
Simplistically,
across.
because edges indicate where spatial change has occurred.
Yeah, it's actually a better way than I just described it.
In this
Nope.
In this example image,
Maybe.
we have background and we have a box. The back
Okay, so that can all go. That can all go. That can go. And that can go.
has occurred. In this example image, we have background and we have a box. The background doesn't change locally and the box doesn't change locally.
When I've got my normal... I think the time of day depends as well, because I had a fairly late night. I think it was about 4 a.m. when I went to bed last night. So today I'm sounding a bit over the weather, which is perfect for... a bit over the weather? Under the weather. Perfect for editing. Let me just... obviously I've done some cuts here, I just need to make
Has
sure that
occurred.
they work on
In
the
this
screen.
example image, we have background and we have a box. The background doesn't change locally and the box doesn't change locally. So there's no relevant information in either of those zones. So one could argue that the box is really only defined by how it is different to the background.
Yeah, it's not a bad argument, actually. At least it's conceptually simple to think about, even though scientifically there's a few holes in that. But
And this difference lies along the edge of the box. So detecting edges is quite an important step. And perhaps the most classical way to detect edges is using Sabel's edge detection.
I know it may seem slow for the viewers, but I'm quite pleased with the pace that we're getting through
Which
here,
is a
'cause the
pair of
last,
kernels
few bits are quite quick.
Used in a convolution. The two kernels detect edges in the two main directions. We've got horizontal. The kernel looks something like this.
I'll speed that clip up.
And we've got vertical.
Okay, so we can ditch you, and we'll change your speed. I'm going to go for a 10,000. Oh, so just 1,000. Yeah, looks good.
It'll look something like this.
I like to leave in the drawing sound. You might not be able to pick that up on the Twitch feed, but it changes the pitch, of course, of the audio,
Something
and you
like
can hear
this.
my pen.
And we've got
Scratching
vertical.
around. Same sort of thing. Just find where that ends. There. Okay. So we'll cut that out. Ditch you. We can ditch you as well. I mean, we're ditching a lot of the camera stuff. And change your speed to the same. Just have a quick save. Let's just see how
The
that
kernel looks
sequence
something
works.
like this. And we've got vertical. If we convolve the image with the horizontal kernel, we will see the horizontal edges. And then we'll convolve the image with the vertical kernel and we'll see the vertical edges. We'll then combine the horizontal edges and the vertical edges into a single output image to show us all edges.
Yeah.
Edges.
There's a risk with this series, because this is a topic that's close to my heart, that I would go into off on all of these tangents of incredible levels of detail, and I really didn't want that to happen, and I'm fairly fortunate it doesn't seem to have done just yet. Now, if I remember yesterday adding that on, thinking I'll need to leave a couple of lead-in seconds on the clip.
Show us all edges. As before with the motion
yeah.
detection, the sign bit of the result of these convolutions can contain useful and interesting information. But I'm going to throw it away by taking the absolute value of the results of these convolutions.
Fair enough.
Is the case confused as to what should be. The Sibel part of the code is exactly the same as the convolution part of the code before, except I'm doing the two things at once.
Yes and no. You can do it. You can do it with either, as long as it's balanced.
I'm maintaining two summation variables instead of the one. And when I'm writing the output summation,
has he got 0 viewers?
And when I'm writing the output summation, I'm taking the average of the sum for the vertical and sum for horizontal components. Instead of the one. And when I'm writing the output summation, I'm taking the average of the sum for the vertical and sum for horizontal components. I have defined two additional kernels in exactly the same way as I did before.
A little error there.
Components. I have defined two additional kernels in exactly the same way as I did before. Now, interesting thing, I've just looked at this code and see that for horizontal lines I seem to have the vertical kernel, and for vertical lines I've got the horizontal kernel. So I'm just going to change that around, fix that up, and redo that section, just redo that little bit. But then it's making me think, have I done that right in the OneNote? So OneNote horizontal should be, yeah, 1, 2, yeah, so that's okay. Sum for horizontal components. I've defined the kernels for Sibel in exactly the same way as I did before. They're just arrays of floating point values.
I imagine if people watch this, some people may think, oh, that Javid X9 is a complete cheat. What a fraud! He can go away and edit his values. The difference, I think, is that they can come and watch a live stream at any point, and we can still do all of this sort of stuff.
Here is the demonstration program running the Sibel edge detection algorithm, and as we can see, edges are illuminated, and boring surfaces, i.e. those that have low frequency spatial information, remain black.
Now that's interesting. There's a change in vocal sort of timbre there, because as I'm waving the book around, I've moved away from the main camera, main microphone. Not much I can do about that now.
It's quite a visible.
In the also in the precursory live streams for this, we actually looked at variations of Sibel as well, which I thought would be interesting, but I think they would just take the video a step too far.
Spatial information remain black. The nice thing about Sibel is it works on this grayscale input, and you can see it starts to highlight all of the areas of high frequency information. So look at my really hairy arm there. It's quite a visible thing. So that's really indicated texture.
I think that's all I'm going to say about Sibel. I know in the previous videos we looked at sort of artificial, that's what I've just said. So, bit, whatever the next one is. Okay. Just taking a few, yeah, I was just reviewing what the code was, so I think that's where we start. So all of that can go.
Bit 6. Morphological operations.
Would it be smarter to take the highest change and not the average change? In what algorithm? In Sibel?
Bit 6. Morphological operations.
Keep watching geometry.
Even though that sounds like a mouthful, morphological operations are really a study of how things look spatially in the image.
Because I think I answer your question in this bit where we kind of imply that with the way that we're performing the morphological operation.
We want to do things regarding the shape of objects in the image. And we do this by working in the binary domain. So we must threshold the image first to binarize our pixels to 0 and 1 values. Binarize our pixels to 0 and 1 values. And for this bit, it's really split into 3 different bits. The first I'm going to look at is called erosion.
You don't need to see me write out the word erosion. It's not that exciting. So this would be an example where I just let a couple of fractions of a second flow of me starting to write it, but then I just cut to the final word. Obviously I stopped for some reason. There's a big chunk of time. So when this plays back, I think it looks
erosion.
Okay.
In this simple demonstration image, I'm assuming that the background is 0 and my object is 1. Erosion is the effect of eroding a single pixel off all edges of our object, effectively shrinking it.
So that's a candidate for being sped up. We'll go with 500
of our object, effectively shrinking it. And it's useful to remove erroneous, spurious pixels from other stages of image processing. Because if I had a single pixel like this, or a cluster of a single pixels in a line, and I eroded it, then if we're removing a 1 pixel from all edges, it's going to disappear entirely. Whereas larger objects, their morphology remains intact.
There's a lot to do. I think I cut to camera at some point. So there's a whole load of really cool and interesting things you can do with this technique. And this video is really just scratching the surface.
The opposite to erosion is dilation. And it is quite literally the opposite. This time we grow a 1 pixel boundary around our shape.
It seems like I swallowed rather loudly there, so I'm going to cut that out.
This time we grow a 1 pixel boundary around our shape.
Hello. Undo. Seems to have deleted a lot of stuff there. Do not do the cut. Do the cut. There we go. Whenever something goes unexpectedly, it's time to save.
So just going back to the previous example, if we had some spurious small information, and we first erode it to remove it, and then we dilate the image again, there's nothing here to actually dilate, but our original shape will go back to something very similar to how it was originally. So this is a nice way of removing spatial noise from an image. In many ways, implementing morphological operations is very similar to convolutions, but this time we use logic instead of dot products. Looking at erosion, we use a very similar 3x3 kernel to how we used in the convolutions, but this time my kernel is just going to be a 3x3 matrix of logic 1s. For every pixel in my source image, I overlay my morphological operation kernel for that pixel. So let's, for example, say I put it here, centered around this pixel. I then do a logic AND.
I'm deliberately leaving that pause in whilst I'm drawing it out because there's a lot on the screen. I need the viewer to be able to actually see what is it that I'm talking about.
I put it here.
If I just made that appear, it might not be as obvious.
Around this pixel. I then do a logic AND with all of the elements in the kernel and all of the elements in the image. In this case, we can see that 1 and 0 here is, well, 0. And this one's going to be 0, and this one's going to be 0. And once we've ANDed all of those together, the end result is going to be 0, because we've got some zeros in there. So I will write to my image 0. However, when I get round to operating on this section of the image, the result is a logic 1. Because all of the kernel coefficients and all of the surrounding neighbourhood pixels are going to AND together to give me a 1. This pixel that was on its own has been eroded, but this pixel that is robustly supported by its neighbourhood stays intact.
Yeah, I think I was a bit worried that how this one would play out because it's not the most interesting thing to visualize, but it seems to be coming on okay.
Instead of just doing logic AND, we could also do some simple arithmetic. We could count how many of our neighbours are equal to 1 and come to the same conclusion. So in this case, I've got 8 neighbours all equal to 1, so my current value pixel is a 1. But in the original scenario, only 3 of my neighbours were 1. So I could then look for less than 8 neighbours, and in that condition, I set myself to 0.
So yeah, when I'm recording with the pauses, it sometimes doesn't feel like it flows quite as well.
Only 3 of my neighbours were 1. So I could then look for less than 8 neighbours, and in that condition, I set...
Still a bit of a pause there. So I'm just going to chop that one to there.
8 neighbours, and in that condition, I set myself to 0.
Yeah.
Now the thing that's interesting... Now the interesting thing with erosion and dilation... Now the interesting thing with erosion is that one man's erosion is another man's dilation. If I inverted all of these bits and applied the same kernel, I would have the effect of dilating the image.
Which is true, but in the code I go to do it in 2 different ways.
Of dilating the image. But I can also dilate in a second way without requiring this inversion. And this one is quite simple. If a given pixel exists, then set its neighbours to exist as well.
Okay, a bit of an awkward stumble there.
If a given pixel exists, then set its neighbours to exist as well. Its neighbours to exist as well.
Feels a bit better. Most common killer. Thank you very much. Bit of a different stream than usual today. I'm showing the editing of one of the videos I'm about to release on my YouTube channel.
And we're not far from the end now. I've got another 2 bits to do. And this would have the effect of growing our object by 1 pixel along all edges.
And did I record yesterday the need for homogeneity across the frame? I can't remember, so I'm hoping that I did. Yeah, this bit was a bit strange. I might cut this entirely. Let's just have a look.
Before I get stuck into the code on this one, I just want to show visually Before I get stuck into the code on this, I just want to show visually another useful thing for dilation. That if I can identify a particular point on an image, let's say here, and I repeatedly dilate, I can effectively flood fill in the image. Now, there's an important condition here, is that after every dilation, if we logically AND that with the original image, we'll never go beyond the boundaries of the original image. So this allows me to fill a secondary image with just the space occupied by a single shape in binary space of the input image. And this is a great way for doing image segmentation, the extraction of objects or labeling image parts.
You know, that actually worked okay. It was a big chunk. I think I'll keep that in. Because that yeah, okay, that segues into then this. Obviously here I've got my Zippo click. See? So I can. This is obviously a 2 camera section. So I'll just pull in the camera feed again.
In fact, I find this to be really interesting, and I think it's worthy of a video in its own right. I've got some interesting examples of how we can demonstrate that, so expect in the near future a follow-up video to this, just showing morphological operations.
I think that's accurate. I would like to do a follow-up video. Have I ever done a part whilst re-editing because I didn't like it at all? No. For the very same reason that you've already pointed out, my voice changes a lot during the day, so it doesn't work for me to go back and redo something. And I mention actually in the whole footage for this, even though I know it's 2 hours long of basically the back of my head, but one of the things I went on to talk about was that if I make big mistakes, such let's say I get an algorithm wrong, I'll keep that in. So excuse me, I'll keep that in the video. Typos and things I'll cut out, but if I get sort of 10 minutes into it and then realise, well, hang on, I've made a mess of that, I'll keep it in because it's human and people make mistakes, and I think no programmer should expect to get everything right first time. And it does seem to be now rather humbling that some people do tend to look up to me as a programmer, whether rightly or wrongly, and I think it's important that they see that message.
In fact, I find this to be really...
So I'll keep that, and I'm going to ditch the the stream feed there. Just to chop a few of these out as well, just so it gives me a marker when I'm zoomed out as to where did we start looking at the camera. And that was the other one, wasn't it? So let's just zoom in there. There have been a couple of occasions where I've found a word which just doesn't make any sense, or it's not come out clearly because I've mumbled it or something. So I'll say like and yes, and today we're talking about reclusion in the class objects, and it's sometimes I've got to go back and perhaps just voice over that bit. I hate doing it because it stands out like a sore thumb on the final video. Just make sure I'm not deleting the wrong things here. So I want to go to you, and you. So that just gives me some space to put my cursor in to get rid of all of those. There were no other 2 camera sections in any of that. No. Just make it too obvious. So today we're talking about recursion and we can chop away all of that. So as you can see, it's a time-consuming process. But fortunately, we're on the home straight now. There's not actually a great deal left because the last 2 algorithms were simple to implement. I might do a spoofing. I've not done a particularly funny video this year. I don't know why that's been. I've got to be in the mood. I like to do the silly ones. I think since the channel's been getting larger and larger, I'm a little bit more afraid to start putting out the silly stuff. You always get some nerd that goes, "This is not what I subscribed for. I'm definitely going to unsubscribe because you're not producing the kind of content I expect of you." I think the internet's a strange place.
Morphological operations.
In the code, the morphological
Well, let's ditch the audio and video feed now.
section is the largest.
So let's just see how that transitioned. Oh, black screen.
In the code, the morphological section is the largest of them all. It's got a great degree of user input, one to select which particular dilation or erosion operation are we going to do. There's also a third one called edge, which I'll talk about when we get to the code.
And the one thing I love about the programming community is I love the dedication and the passion of its people, but sometimes they just take it a step too far. Step away from the keyboard.
But I can also control the number of times that I perform the dilation or erosion, and so we'll be able to see those effects visually. But the first thing and the most important thing is we need to take our image from the grayscale domain into the binary domain. So I'm just thresholding it, and I'm going to threshold it using the value that we've specified in the threshold algorithm. So this will allow you to tweak the threshold first.
Okay, I like that. We'll just... almost did a Da Vinci death sentence then. There we go. As you can see, I always do these sort of big slices through all of the videos. Da Vinci has an interesting way of, if you select things which aren't quite aligned and press delete, it sort of interprets what you want in a strange way. It's as if some programmers forget that ultimately there is fun
allow you to
be
tweak
had
the
here.
threshold first. Then we go on to choose dilation, erosion, or this third one, which I'm calling edge, because it's going to be an edge detect.
And nothing, I'm sorry to keep going on about this, but nothing annoys me more than programmers that forget that at some point they didn't know how to code either. So give the guy asking a stupid question a chance. Just give him a break.
Dilation, erosion, or this third one, which I'm calling edge, because it's going to be an edge detect using morphological operations. For dilation, it was simply a case of seeing if a given pixel value was equal to 1, then set all of your neighbours to 1 too. Easy enough.
Okay.
But I use this third register activity because I don't want to alter the frame as I'm going through the pixels. It's important that the whole frame is treated homogeneously.
Nah, so I did say it, but I said homogeneously. Now I must have
It's important that the frames are treated homogeneously.
There we go. Now it depends where you're from, how you pronounce that word. I think people are more acquainted with homogeneous rather than homogeneous.
It's important that the whole frame is treated homogeneously. It's important that the frames are treated homogeneously. It's important that
Yeah, I think a lot of people do pronounce it the second
It's
way.
important that the frames are treated homogeneously.
But you don't say Homo sapien, for example, do you? Although some people do. So
For erosion, rather than doing a set of logical operations, I decided to go with the summation route. So I'm looking at all of the values of my neighbours, and all of the ones that are 1 I'm summing together. Now, I know that in my activity frame they're going to be 1s or 0s anyway. We've binarised the image, so I'm just going to add them. And I'm going to check to see if my activity is 1, and if it is, but not all of my neighbours are set to 1, then I'm going to set myself to 0, put myself out.
the video is looking like it's half an hour rather than 25
This third
minutes.
one, which I've not drawn up in OneNote, I've called Edge, and it's exactly the same as erosion. But instead of looking for a less than 8 neighbours, I'm looking for precisely 8 neighbours. So in the situation that I am precisely 8 neighbours. In the situation that I am an illuminated pixel and I have all of my neighbours, I'm going to extinguish myself. So let's take a look.
So this is, I know I said keep watching geometry, I don't know if you're still there, but if you are, this is, I think, what you were referring to regarding the edge detect.
So let's take a look. The program has started up with the thresholded image, and this is just so I can tune the threshold value appropriately. I can still tune it later on, but it's just a bit easier to do whilst looking at the grayscale image. Then I'm going to choose bit 6, more binary morphological operations. Then I'm going to choose bit 6, more binary morphological operations. Now the current operation is dilation, and it looks like there's just a single iteration being applied. So on the left, where these individual pixels are occurring, you can see they're expanding into a 3x3 region. This has had the effect of removing the one lone coder text entirely from the book object. So this might be a precursory stage in being able to extract where is the book this time, if that's useful. Excuse me. I can increase the count I can increase the number of dilations with the A and S keys. And as you might expect, a way of grouping things this time, if that's useful. I can increase the number of dilations with the A and S keys. And as you might expect, the regions just grow. So dilation is a way of grouping things together. Erosion is a little different. Here on the left, those spurious single pixels have all but disappeared, as has a lot of the noisy background, so erosion has really just allowed us to focus on the core parts of the image. If, for example, I eroded this image and then dilated it, well, I can't bring any of that background noise back in. We're looking at the eroded image now. If I dilated this, there's no source pixels to seed anything for dilation.
Sounds like in my headphones there's an airplane going over there.
So combining these two operations is a nice way to remove noise. Let's add multiple erosions, and eventually we can erode the image away entirely. Erosions and dilations, as I demonstrated very briefly, can be used for detecting and labelling objects individually.
Yeah, but I don't actually go on to demonstrate that, so we might want to start cutting here.
And in a primitive way, they can also be used for sizing objects. If you continuously
Oh yeah, okay, we'll keep that in. I forgot that I talked about sizing.
And in a primitive way, they can also be used for sizing objects. If you continuously eroded the scene and looked for the finally illuminated pixel, you could then dilate that pixel and logically and it back into the scene to highlight the largest object. So you could use erosion and dilation for sizing too. Now finally, there's one more mysterious one. If I press the C key, and that is using morphological operations to detect edges. And this gives you a really nice edge detect where all of the edges are a single pixel.
Now you see that sizing and object identification stuff, that would make an interesting video in its own right. I think I'll add that to my to-do list.
Edge detect where all of the edges are a single pixel. If I bring my hand into the scene, it's a bit messy. Let's find a nice high contrast scene. There we go. So that's quite nice for isolating all of the buttons. Now you'll see the camera is adjusted in gain there. Not much I can do about that. But this is different to Sibel in that it gives you a really crisp outline edge for an object.
So this looks like it's me rattling on about the other video.
Getting through it.
Yeah, okay. So we can get rid of that, and this looks like potentially the start, bit 7. Bit 7. So these last two are much quicker than those. So they're the two big chewy ones. So we're definitely on the way home now.
Bit 7. Median filtering. When working with real-world sensors, things don't always go to plan. Sometimes your image will have little tiny artifacts in it. These are bad pixels or snow, depending, it might be in a radioactive environment for all I know, but you end up with something which doesn't look quite right. And these are usually quite tricky to filter out.
Okay, let's just tidy that up a little bit.
Quite right. And these are usually quite tricky. Doesn't look quite right. And these are usually quite tricky to filter out, unless you use a median filter.
The thing about median filters is, mathematically, I always find the median function quite curious, because there's no maths to it. It's just, we'll just take the one in the middle. And yet it's used in so many things.
Median filters are conceptually very simple. In a similar way to convolution, for a given pixel, we look at its immediate neighbourhood. In a similar way to convolution,
what's the most useful use case you know outside of image processing for median filtering? It's often used in statistics. I just find it's just a curious thing that you just sort your numbers and take the one that lies in the middle.
Convolution. For a given pixel, we look at its immediate neighbourhood.
So I don't want to draw out filling out dots, things like that. Not very interesting.
In this example, I'm using a 5x5 neighbourhood.
Is it not very useful? Well, I think that's probably because it has no sort of sound mathematical theory behind it. Where have I seen it used? So I was looking at my wife's a teacher of young children, and in order to do that, she has to go on courses to train them in how to analyse marks and grades and attendance and that sort of thing. And they were looking at using statistical medians as a way of finding the grade boundaries amongst what the results indicated from the students. So obviously when you do exams, you never know how hard an exam is, so you need to look at the marks and then decide where the grade boundaries need to be. And certainly using median
In
as
this
part
example,
of that.
I'm using a 5 by 5 neighbourhood.
Why have I got a gap there between 5 by 5 and neighbourhood? Why couldn't I just say the word neighbourhood at the right time? Why does my brain work like that?
5 by 5 neighbourhood. And we're going to make an assumption in our image that we're not really expecting spatial change to happen over a single column.
You know what?
Change. Really expecting spatial change.
Well, take out that it's sort of the first one that's stuck in my head.
Not really expecting spatial change to happen over a single column of pixels or a single row of pixels. That's quite unusual in natural images. So it tends to be that in general, information in images is rather blurred out across the image.
On the whole, I don't think I'm an kind of person, so that's why I don't tend to include them. I certainly repeat myself, but I don't think I'm a all the time.
So up here,
Clearly I'm ignoring the evidence that's right in front of me and covering it up.
where I've got this single erroneous pixel, I can make an assumption that most of my image in that region is behaving one particular way, and that this black pixel is some form of outlier. And we can statistically remove the outlier by looking at what the median pixel value is across all 25 pixels in this 5 by 5 kernel. Now, if you don't remember what the median is, you take all of your values and you sort them in order, and you take the one that lies directly in the middle of that sorted set. It's one of those quirky mathematical phenomena where it sounds really complicated mathematically. Phenomena where it sounds really complicated mathematically, but there's actually no maths involved at all. It's just a sorting and an extraction.
We were discussing that before, Nave. There's plugins to do that in this software as well. I tend not to, because I mentioned when this came up before that my videos have a sort of pace to it, and I appreciate that a lot of my videos are quite long, but I certainly get very positive feedback about the pacing of the videos. And what I don't want it is to just be this big smash of jump cuts and just non-stop dialogue all the way. So I don't. Also, it gives me a chance to go through it and make sure things are said the way I intended them to be said. And I sometimes creatively leave little pauses in that I think are
Sorting
right.
and an extraction. For the median filter code, as usual, I'm iterating through all of the pixels in an image. Start again. For the median filter code, as usual,
It's like my mouth just stopped
filter
working.
code,
Then.
as usual, I'm iterating through all of the pixels in the image. And I'm not trying to optimize this at all. I want the code to be readable, and so I'm going to do something really horrendous and create a vector of the floating point values, which represents all of the pixels surrounding the pixel I'm currently investigating.
Just let that play through.
Over this 5 by 5 area. And all I'm doing is extracting those pixels in my neighborhood and pushing them into the vector. Once I've got 25 pixels in my vector, I then sort them using standard sort. Since I've got 25 pixels, the one in the middle, it will be at the 12th location.
Do you know how much grief I'm going to get from somebody saying, oh, you should not be using standard sort in a tight loop like that, simply because there are faster ways to do... They just like completely miss the point. I don't want to overwork
surrounding
myself.
the pixel I'm currently investigating over this 5x5 area. And all I'm doing is extracting those pixels in my neighbourhood and pushing them into the vector. Once I've got 25 pixels in my vector, I then sort them using standard sort.
I didn't know in standard sort, maybe obviously you lot will, about these sort of built-in, ready-to-go ones. Standard greater and standard less than. It's just something I'd never done. I've always just manually typed in the predicate. But then it popped up in IntelliSense, and I just thought, you know what, I'm just going to run with it. Works a treat.
Standard sort. Since I've got 25 pixels, the one in the middle, it will be at the 12th location of my vector. And that's what I'm choosing as my output value.
Yeah, a nice quick bit, this one, because there's not a great deal to...
It's pretty simple, huh?
See? Yes. Yes, it is, Javid. It's pretty simple.
And so here in the demonstration program, I'm now running the median filter. And you might be at first thinking it's just blurring the image, but it's not. It kind of looks like it's painted it a little bit. So I'm sure median filtering is used in some of these Arty Effects programs. But I do have used in some of these Arty Effects programs. But I do have a test image that I've created here, where I've got the words median filter written on my page, and you can see the median filter has filtered out the lines because it sees those as anomalous.
Hey, Alex.
And it's also filtered out the dots. But there's sufficient information left in the text to then go and extract it using thresholding or morphological operations or something else. So it's just a precursory phase to help you with later stages of image processing.
We'll just cut that out, but I think it's going to snap.
Just a precursory phase to help you with later stages of image processing. Once the dots get large enough that they occupy a region, in fact, even so zoomed in like that, you really would struggle to identify the dots, but the text is just fine. So when you get this sporadic salt and pepper noise in your image, median filter is the thing to choose.
Right, I think we're on to... yeah, the last bit.
Bit 8.
It's like said with enthusiasm there. Bit 8! It's like, yes, we're almost done.
Bit 8. And finally, bit 8, locally adaptive threshold.
Oh, see, I must have thought that at the time. Oh well.
And finally, bit 8, locally adaptive threshold. I started this video by looking at a threshold. I started this video with bit...
It's always the case. I get more errors when I get towards the end of the video now. So I get a load at the start, but then towards the end I'm sort of thinking, yeah, I kind of need the toilet and I need a cup of coffee and come on video, let's go, let's go, let's go.
I started this video with bit 1 looking at thresholds that were applied globally across the image. More often than not, this is sufficient, but there are situations where you want to threshold an image based on local information. Working under the same principle as the median filter, we make an assumption that overall, for a small region of image, there's not going to be a great deal of spatial variance. So it's better to choose a threshold value based on the information in your locality, or at least bias towards a threshold value found from the information of your neighbours.
Do I repeat that, or have I got to tidy that one up?
So I know, for example, in this region of the image, if I...
Oh dear, right, okay.
So it's better to choose a threshold value based on the information in your locality, or at least bias towards a threshold value found from the information of your
Let's try and make that a little bit more fluid.
in your locality, or at least bias
Hi,
towards
Dragonite.
a threshold value found from the information of your neighbours.
It's a bit better. We'll run with that. Nobody will ever know. Keep it quiet, guys. Don't tell anybody.
So I know, for example, in this region of the image, if I take the average value of my neighbourhood, then things that are statistically interesting may be a certain level above that average.
Stupid. Often happens. I live not far from the countryside, so lots of farms around where I live, and we get lots of wildlife and things in the garden. I really quite like wildlife. I'm a bit of a bird watcher, but we get lots of birds appearing on the sheds and roofs around, and one's right outside my window here. And so sometimes it just comes along and it sits there and it squawks and it clucks and it tweets and all this thing whilst I'm trying to make the video. And no matter how much I tap on the window or tell it to go away, it always keeps coming back. I can just hear it then in the background on this.
The average value of my neighbourhood, then things that are statistically interesting may be a certain level above that average. And that average might be different for different parts of the image. Different parts of the image, which means if I used a global threshold,
Yeah, you can hear it throughout all of this. I don't know if you guys can hear it on the stream, but it's definitely
statistically interesting, may be a certain level above that average. And that average might be different for different parts of the image, which means if I used a global threshold,
it's gone now.
that threshold value may not be appropriate for different regions of the image. And locally adaptive thresholding, it may not be immediately obvious what locally adaptive thresholding is for.
Okay, so we've got a bit of a context change there, so I'm going to have to think this one through. Just replay from the
Parts of the image, which means if I used a global threshold, that threshold value may not be appropriate for different regions of the image. And locally adaptive thresholding, it may not be immediately obvious what locally adaptive thresholding is for.
Did I just restart quite a lot there?
Then things that are statistically interesting may be a certain level above that average. And that average might be different for different parts of the image, which means if I used a global threshold, that threshold value may not be appropriate for different regions of the image. It may not be immediately obvious what locally
It's okay.
adaptive thresholding is for. But I've certainly used it the most. No. It might not be immediately obvious what locally adaptive thresholding buys you compared to a global threshold. Different regions of the image. It might not be immediately obvious what locally adaptive thresholding buys you compared to a global threshold. But I find it really useful when you've got change in luminance across your scene.
That's a stupid thing to say. You got change in. I mean, your entire scene composes only of change in luminance. But I think in the context of what people are saying here, seeing here, that makes sense because I've referred to the pixel values as brightness, but now I've brought in the term luminance. That implies light in the scene. So I'm hoping that will make people think a little differently. So it looks like I've got a Zippo thing going on. I have.
Change in luminance is just a fancy word for shadows.
Right, okay. So I do actually go away and correct that. Let's. Looks like a turn to camera.
Change in luminance is just a fancy word for shadows.
Right, good. So I did go and explain that. Forgot that I did that.
Change in luminance is just a fancy word for shadows.
So that we need to do a bit of housekeeping then. So you can go and you can go, and we'll find where was the last cut to camera. Quite a way back. There, you and you. And we'll get rid of all of you in between. Then we carry on. Just shut off the video feed and go back to the screen feed.
The code for this algorithm is something we've started to see. We're now getting quite familiar with the code for these algorithms.
Okay, good.
With some user-defined constant, and that constant is user configurable via the user interface. Before we go on to threshold.
What sounded awful? Have I missed an audio glitch?
We're now getting quite familiar with the code for these algorithms. We're going to iterate through all of the pixels, and in this case I'm going to take the average value of my immediate neighbours 5 by 5.
Oh right,
But
that's okay then.
I'm then going to use that average as part of my thresholding calculation.
I like this one. I'm glad I've changed this one to be bit 8 because I think it's sort of the most interesting one and visually the most impressive one too. So it's a nice way to
Region
end the
sum
video.
contains the average, but I'm going to bias that value with some user-defined constant, and that constant is user configurable via the user interface before we go on to threshold the image. So let's take a look.
Now, usually when I say, so let's take a look, because that's one of the things you'll hear a lot in my videos, I do actually show the sort of compilation and build phase, but I'm not in this one, since we're already sort of 10 minutes over what I expected this video to be.
So let's take a look. Here I've got the input and output showing just the regular threshold. This was the one we started with, bit 1, and I can try and find a value which sensibly thresholds the image, but you can see it's a global effect. And one of the things I wanted to show here is that the shadow cast by my hand is influencing that threshold decision. I'm going to press the 8 key now to choose the adaptive threshold, and we can see straight away the difference is that my shadow has basically become irrelevant to the scene. The local area around each pixel is used to guide what value we're using to threshold it against. And so the areas in shadow have overall lowered the threshold value, and the areas of brightness overall have raised the threshold value. And so we're choosing a value which is varying across the screen in order to make our thresholding decision. So if you wanted to make things that are shadow and luminance invariant, then you probably do need to use some sort of locally adaptive thresholding algorithm. It's also quite a cool visual effect too.
That was nice. That was a good solid chunk of dialogue. And so I think I've almost done. I think that's it. Right. So now we need to do the outro.
Anyway, that's it for now. If you've enjoyed this video, give me a big thumbs up. And that's that. I think I covered.
Okay.
As I mentioned in the introduction, you don't always have to work with images. Procedural generation may also employ a lot of these techniques too, particularly the morphological operations.
Right. Just bring in the main video and the main feed.
And so that's that. Image processing is a huge field, and for me I find it to be a very interesting one too. In this video we've had a very quick look, a very cursory introduction to some of the most fundamental techniques you need if you wanted to start doing image processing. As I mentioned in the introduction, you don't always have to work with images. Procedural generation may also employ a lot of these techniques too, particularly the morphological operations.
Okay, so it looks like I'm not sort of repeating and cutting here. So let's pull that in. So we need the trademark turn. That's what that's going to be called from now on. I didn't realise it was a thing people had locked onto.
Holding algorithm. It's also quite a cool visual effect too.
And so that's that. Image processing is a huge field, and for me I find it to be a very interesting one too. In this video we've had a very quick look, a very cursory introduction to some of the most fundamental techniques you need if you wanted to start doing image processing. As I mentioned in the introduction, you don't always have to work with images.
This is DaVinci
Procedural
Resolve.
generation may also employ a lot of these techniques too, particularly the morphological operations.
Good, we're getting there, and then there's only sort of a couple of steps left to do.
Anyway, that's it for now. If you've been particularly the morphological operations. Anyway, that's it for now. If you've been
That's a bit tight, that one, actually. I'm just going to undo. I'm not quite happy with...
Anyway, that's it.
So I actually start talking about the...
logical operations. Anyway, that's it for
That's
now.
better.
If you've enjoyed this video, give me a big thumbs up please, have a think about subscribing, come and have a chat on the Discord server, and I'll see you next time. Take care.
Leave it a little bit to fade. Right, and then so we've got the remainder of yesterday's video. So we can start to save. Let's clean up a little bit now the stuff that we're not using. So that was all to camera, and the to camera stuff started there, I think. Yeah, trademark turn. So we'll just get rid of that and identify you for erasure. And I think that one is there. So that, to me, looks like the entire video that we've just edited, because there wasn't too many parts to camera. So there's a few stages to do to finalize this off. The first is I always put in a fade at the beginning and the end, just of 1 second. So this is a count in frames going across the screen. So 25, there we go. So 1 second fade in and out. Go to the end and do the same. 1 second and 1 second. So that this will have the effect of in the audio sphere it brings the volume of the audio down, and for video it just fades to black. Now because I've been zooming around the whole video, it's not going to play immediately. It's caching all of those changes we've just made. You can see how all the thumbnails have disappeared. It's got to load those up, so we'll just give it a couple of seconds to catch up with itself. Yeah, it's free. Yeah, the only thing it doesn't do is 4K, and there's a couple of the advanced temporal GPU filters it won't do. Other than that, yeah, it's completely free.
I'll see you next time. Take care.
Perfect. So that's the fade. The next thing that I need to add is a burn-in. And so it's industry jargon. The burn-in is basically the One Lone Coder logo that I put on the bottom, and I can just pull that in. So if I just plop the cursor somewhere so I can see what it looks like, One Lone Coder load. So I've imported that in, he says optimistically. Load. That's the one that I want. Yeah. Why is that stuck it there though? Tell you what, I want to do that again because I don't know what apology is. Load. There we are. So it's put it in the correct corner. So that's burnt in now. So that'll play across all clips on the video. So I know that it's mine. It's a really competent piece of software. And today, you know, I've been live streaming whilst using it, which because it is a resource hog. It's currently using 24 gigabytes of RAM, and about 50% of my CPU. But at the same time, I'm also doing the compression for the stream and all of the other bits and pieces. Right. So the next phase is to choose a thumbnail. And so we need to think of what's an interesting thumbnail for this. Well, you need to download more RAM, Magetta. Right, so what are we choosing for a thumbnail? What did we like? Obviously I think it's going to be a screen like this, but that doesn't really make much sense intuitively. That one. I don't know. Yeah, it does need a GPU in order to work effectively, because it is what we're looking at now is all GPU rendered. The final video rendering, ironically, is all done on the CPU, so that can take a bit of time. But because it allows you to do all of these real-time effects and things, it does it all on the GPU. I need to find what algorithm did we like for visuals. Just wait for it to catch up with itself. So Sibel's a candidate, maybe. Put a marker there. Sibel. I think that's accurate, Humpa Lumpa, because when I started streaming, I have actually got GPU HEVNC capability for encoding, but I was never that satisfied with the results. Morphological operations I don't think are particularly interesting. I quite like the last one actually, the shadows. What do you think? Something like that for a thumbnail? Bit too noisy for a thumbnail. Come on, guys, give me some thumbnail feedback. I'm waiting. Stop talking about RAM and code. Thumbnails, that's what's important right now. Shadow, so that's that one. Ghost. Oh, great. I think maybe Sibel is the more interesting one. People might not understand what they're looking at there, but something like that, that's a bit catchy. Okay, we'll go with Sibel. So we'll choose that as the thumbnail. So I'll go into colorization mode and grab that as a still. And export it to the folder that I'm working with. And I'll put on the thumbnail text later on. Where am I working? Scratch drive. So this is a drive, a whole hard drive I have just for doing video on. So today's video is 2019, 8-bits image processing. I'll output it rather crudely as a big JPEG. Oh, do you know what? I'll do it as a PNG. Stick it in that folder. Now, typically, I would now go and watch the whole thing for errors and little glitches and just tidy them up if there are any that we've missed. And there might be a couple today because I've been chatting whilst doing the edit. But I'm not going to subject you to watching it all and finding the mistakes. So what I will do now in my own time is all the boring stuff. I'll watch the video, then I'll do the rendering, actually render it to disk. I can show you how that works if you're interested in that. Because I guess we don't actually have to do it. Let me just pull a bit of the screen down. So up here, this is the delivery window. So this is what decides how your final video is put together. It's got loads of built-in things at the top. I use the YouTube 1080p one. But at any of these, you can then modify what particular format you want to use, what the codec is, and there's loads built in. You can specify the resolution and the data rates and all that kind of thing. I find it quite intuitive. You can go into advanced settings and there's all sorts of cinema-specific things which I don't fully understand. And that's for video, and you can separately edit audio as well. So for audio, I always prefer AAC because YouTube recommended that's what I should use, which I believe is like an MP3 encryption almost. So it does slow down the render just a fraction, but hey. And specify the nature of the file, where it exists, etc., etc. And then you add that to your job queue and click the Start Render button, and then wait. And so for this one, I don't think it'll take too long. What's the final length of the video? Looks to be 36 minutes. So I think that will probably only take 20 minutes to do the render. So I'm going to render it and do the actual upload to YouTube bit behind the scenes, because that's boring watching progress bars. But I might live stream later the final phase of preparing the video and actually doing the launch and seeing how people respond to it. Put a Fortnite screenshot. Maybe we should put some Minecraft on it or something like that. Because there's also a little bit left to do with the code, so I need to put the licensing stuff on the code. So we'll probably do a little follow-up stream later on once I've done all of this boring stuff. But thank you guys. I know not a typical stream from me. I won't be doing another one of these in the foreseeable future. I don't want to do it for every video. I just wanted to capture one particular sequence of videos. And I think that is that. So thank you very much, and I'll see you all later. Take care, everybody.